So I was watching a video by the game developer Pigdev. He was talking about the easiest games to get into game development, and it got me thinking, what are the game jars that are easiest to start as a programmer, and what are some of the really difficult game jar that maybe some people don't expect to be so difficult? Now, there's a lot of things that makes game development especially complex, whether it's all the art-related stuff, or the game design side of things, or just the programming of all the game rules inside the game. But I think there are some jars that are much easier to tackle as a beginner, and some jars that maybe are way more difficult than you expect. Of course, a quick disclaimer here before we start. This is all based on my own personal experience and opinions, so of course it's probably not going to agree with all of you, and I'm probably not going to talk about your favorite jars. But if you feel I haven't talked about a specific jar, or if you are curious about my opinions about a very specific games, please sure to leave a comment below and I'll try my best to reply to it with my own specific ranking for this specific game or jar. But for now, let's start with the number 1 easiest game to program as a beginner game developer. This is something I don't see many videos or online tutorials talk about, but if you want to learn or get into game development, trying to remake some traditional board games on the computer is one of the best ways to learn the fundamentals of programming. There's plenty of games out there that are very easy to implement inside a computer with very well-defined rules. I'm talking about, say, implementing a game of solitaire, or maybe re-implementing tic-tac-toe or a chess game. Maybe a chess game has a very complex AI that is really hard to implement, but there's plenty of tutorials on how to do it, and if you just want to implement the basic rules and play with your friends on the same computer, it should be something very easy to do. I mean, you can even implement the tic-tac-toe on the console of Windows, and it's gonna work pretty fine as a first project. And it's great because you don't have to think about what the rules are. You already know the rules. What you have to think about is, how do I translate, for example, the winning condition in tic-tac-toe into something that a program is going to understand. That's probably why in my university classes we often use these kind of games as projects for the material we were learning at that time. Now that you've explored data structure, loops, conditions, and translating simple rules into programming language, it's time to move up to the second level of game development, and I think this should be casual games. And by casual, I'm talking, of course, about Flappy Bird or Candy Crush or maybe Angry Birds, these type of games that usually have a little bit more fancy game logic, maybe a little bit of physics, and maybe some more pretty graphics, but still usually keep to one single gameplay loop without too many other factors around it. And by that I mean that, you know, Flappy Bird is really just one button input, and it's really just applying a little bit of fake gravity on the bird and having some collision detection. And Cut the Rope or something like that, or Fruit Ninja, it's all about, you know, a single type of action that you perform, which makes it easier to tackle as a beginner developer when you only have to concentrate on making a single little gimmick works. One caveat with that is, if you look at the Play Store and the most popular mobile games and casual games on the market, you're going to think, but why do they need like 100 people working on these for like 3 years to make such a simple game if it's the number 2 in the list? And the reason for it is mostly because of all the online meta progression and social aspect that they add on top of the basic game loop. And here, I'm really just talking about implementing the basic game loop as a single player game. If you're going to try to make the request heart to your friend and all these meta progression things and the online servers and all that, well, that's a whole other level of complexity that is not what I have in mind at this point. Now for the level 3, I would go into adventure games, or what sometimes people call also walking simulators. Now, the reason I rank this a little bit above casual games like Angry Bird is because usually walking simulators, or especially adventure games, will require some level of branching narrative and some more complex interdependent logic system that will make your code a little bit harder to implement.
When Stanley came to a set of 2 open doors, he entered the door on his left.
On the other hand, these games usually also keep graphics to a minimum, though they might require some much more beautiful sceneries and some small animations. It's usually possible to keep it to a bare minimum while still being interesting. So the whole point is that it's going to be more difficult to think about the game as a whole, because you're going to have to consider all the different paths the player can take and all the different interactions and how all of these are going to be resolved inside your code. And that makes it, in my opinion, a little bit more complicated to implement as a beginner programmer. Now we get in the fun part with level 4. This is the single most popular tutorial on the planet. I'm of course talking about platformers, and actually I'm going to include with this roguelite type of game like Enter the Gungeon or Binding of Isaac. And the reason for this is pretty simple. It's because it's a really good way to wrap up everything we've seen up till now and actually make a game that uses all of the things we've learned to that point. That means that there's a lot of art and game design and challenges to implement, yet things are still relatively simple for someone starting in programming and game dev. And that's usually also where some engines will really come in useful to implement a lot of this stuff for us, like the physics or the platforming elements or the collisions or, you know, changing scenes and stuff like that, that are all already handled by a good game engine. The main difficulty, I think, with platformers in general, like Celeste or Super Meat Boy, is going to deal with the feel of the game, because now we're in real time, where a lot of the other games there wasn't really a concept of developing or moving in real time. Now we have to deal with stuff like input lags and collision precision and making the game feel right while you're playing it. And the really successful platformers out there, they all have this in common, that they perfectly nail the feeling of controlling the character. Still, compared to some of the other jar we'll be talking from now on, the progression and the number of elements that you find in one of those games is still pretty limited compared to some of the other jars we're going to approach right now. And that brings me to level 5, which is what I've been working for the past 2 years or so, and it's traditional turn-based roguelikes. And to that end, you could say just in general turn-based RPGs. Now the reason I insist on the turn-based aspect of the thing is that it's going to really help you break down your system into distinct time chunks that are not time dependent, and that's going to make things a little bit simpler. Still, that's where we're going to start introducing some much more complicated system, because up till now maybe your enemy was shooting bullets and doing 10 damage. But now, in RPGs, you're not just doing 10 damage, you're doing 10 electrical damage with a 5% critical chance on an enemy that has a 20% resistance to electric damage. Now you have to code all of this inside your game, and that gets much more complicated. There's a reason why some traditional roguelikes are considered to have everything, including the kitchen sink. That's because you can go pretty crazy on all the systems you want to implement, up to and including the whole world. Which brings me to number 6, and now we're going to leave a little bit the complexification of the game systems and the logics of the code, and instead go into more of the 3D aspect of game development. I'm talking about, of course, first and third person shooters. Now these games are not that much more complex than simple platformers. I mean, you usually have a couple of guns, maybe a few different abilities, but that's about it. A few platforming elements where you have to jump from one place to another. What really makes them a little bit more difficult than the other jars we talked before is the fact that you can't really do them in 2D. Now you have to really think about 3D and animations and 3D models and things of that jar. And that makes things a little bit more complicated, and I think that's the level where you go from intermediate game developer to a little bit more advanced game developer. It requires some more knowledge and more advanced mathematics to take into account stuff like, you know, quaternions that no one actually really understands. And it's not that it's impossible. There's people working by themselves on a project and making these kind of games like Project Feline, and they can do some really amazing stuff with the right engine and the right tools. But I think it's still a level above some of the other game design. Which brings me to level 7, which is going to be action RPG, like the classic Diablo or Path of Exiles or stuff like that. Now you have all the difficulties of turn-based roguelike without none of the advantages. Now you not only have to deal with the inputs and the feel of platformers, but you also have to deal with all the complex intricacies of really complex RPG systems and designs, and maybe even some craftings and stuff like that. That makes it really hard to put everything together well. And it's something similar for level 8, where we're going to take a lot of what we've learned so far and move it up a step further. And I'm talking about real-time strategy games, because now you're not dealing with only controlling one character with a bunch of special abilities and classes, but having the player control and manufactures hundreds of players, each with different abilities and characteristics and interaction. And that makes the whole balancing and managing even more difficult and even more complex. That said, RTS might be a good way to look at implementing online for the first time, in my opinion, because this is where online games really shine, right? Games like StarCraft or even stuff like League of Legends, they have a limited number of players, but you have to start learning about stuff like sending states and server architecture and maybe online matchmaking and leaderboards and stuff like that. So it's maybe a good place to start. Still, it's not easy, and this is clearly in the more advanced programming category. After that, for level 9, I would go into simulation game. And first, I would tackle racing games. Now, racing games by themselves might not be that difficult to implement, but if you're talking about simulation, it means you're trying to achieve something like realism. Now, if you want to make some arcade racing game with just some basic sprites that look vaguely like a box on wheel, then that's not really the problem. But if you're actually talking about simulating real-world cars, then you have another thing coming. Because even though there's some really powerful physics engine out there, implementing car physics is anything but simple. But the reason I'm separating car physics and simulation from other type of sports and simulated games is because, well, cars are still fairly static bodies. I mean, they don't have much animation beside the wheel moving, and so they still have less requirements than some other games. And by other games, I'm talking about level 10, which are any other kind of sports simulation, like football games or hockey games or, you know, soccer games and stuff like that. These are really complicated. Again, mostly because we're trying to achieve realism, because in the end, these are games that are emulating real-world games, so you have all the rules and all the game designs is already made, but now you have an element of some player doing stuff, or, I mean, not player, the player of the game, but player inside the game, like the characters inside the game represent some real-world players, and they have strategies and behavior trees and stuff that make it all much more difficult. Finally, level 11 and above is any of the previous jar that you want to implement with some online aspect. And that's mostly because I really hate working with online, but also the fact that you have to deal not only with everything from the previous jar, like game design and art and logic, but you add on top of that a whole bunch of new issues like ping, synchronization, server architecture, and matchmaking, and all of these kind of really fun things that you have to implement on top of your game. And with a very special top of the top spot for anything that's massive multiplayer online. And that means usually dealing with hundreds if not thousands of players all at the same time. And that's especially difficult because now not only you have to think about the server architecture and all of that, but you also have to do some really crazy optimization. Because when you're dealing with sending the position of 1,000 players every frame to all the players in the game, you need to do some kind of optimization. And there you have it. These are my, I don't know, 20 level of difficulties for how to tackle game development. So if you want to start easy, start with some tabletop remake and just have fun with it. Maybe add some 3D chess pieces if you want to introduce yourself to 3D development, and just work your way up the list with more and more challenging logic puzzles or art challenges or game designs challenges, and just slowly, surely get to a point where you can implement pretty much any games you want given enough time. And that's gonna be it for this week. I hope that you liked it. Leave a like and don't forget to comment if you want me to rank one of your jar that I haven't mentioned in the video. And see you all in my next episode. Bye!